Hi, and welcome to Enriching GIS Data with Thematic Information using the ArcGIS API for Python. My name's Andrew Chepkowski, and I'm here with Mohit Agarwal. I'm a lead developer on the ArcGIS API for Python. And Mohit, can you go ahead and introduce yourself?
Hi, my name is Mohit Agarwal, and I'm a product engineer with the Python API team. Today, I'm going to talk about some of the concepts of GeoEnrichment along with Andrew.
Thank you. We're going to dive right into it, and hopefully you find this content interesting. So the first things first is, what is the ArcGIS API for Python? And it's a Pythonic API, and it's going to allow you to analyze, visualize, and manage your spatial content in your WebGIS. It provides you with a set of methods and classes to work with that data and make it very tangible. What is GeoEnrichment? GeoEnrichment is about taking information, whether it's a set of addresses, geometries, or known named locations, and providing additional information to it. This can be information like population and census data, income, housing, even consumer behavior data. And it varies, the amount of content varies based on the location that you're interested in. So let's dive right into it. In this demo, what we're going to do is we're going to build a simple tool. When you click on an area, you're able to get the key global facts for that given area. But first, we need to do a few things. First, we need to import our libraries, and we're going to import from the ArcGIS API for Python, import GIS, geometry, and enrich. The enrich method, which is in the GeoEnrichment submodule, is going to allow us to take that spatial information that we're going to get from the map and add the additional census information that we're interested in this case, the key global facts. After we've imported our libraries, we can go ahead and we can connect to our GIS. In this case, I'm going to use my profile to protect my credentials so you don't see it here, but I'm going to be able to connect using a username and password to ArcGIS Online. Now we're ready to go ahead and create our map widget. I'm going to create a map widget that's over New York City and zoom to my area of interest. Here we can see both Manhattan, which is part of New York, and part of New Jersey in Jersey City. Before I do anything with the map, I want to register a function with this. And this is a truly unique thing that you can do with the map widget, where you can wire events to map widgets in order to behave the way you want it. So I'm going to create a function called GeoEnrichment, and it's going to pass in the map object and the geometry to this function. First, I'm going to clear any graphics or remove any layers that it might have before, and then take where I click on the map and project it into 4326, apply symbology, and draw it. Then I'm going to take that study area that we're interested in, that G variable, which stands for geometry, and get back the key global facts and print the results out. So let's go ahead and run that cell and then register it to the onClick event. Now we're ready to click on our map. I'm going to click on an area over in Jersey City, and first you see the point draw, and then right away you see the information show up behind it. When I click on the geometry, you see the pop-up show, and the key global facts show up with it, such as total population, total households, the average household size, and the number of males and females in that given area. Before we go any further, there's something else that we need to talk about, and that's the concept of credit consumption. When you use the GeoEnrichment API, it costs credits, which is the digital currency of ArcGIS Online. Each request has a cost. So for what we did in the previous example, when we clicked on an area, that was considered we passed one feature. And we used key global facts, which had 5 variables. So for each GeoEnrichment request with key global facts, it's going to cost us 0.05 credits or $0.005, which isn't very much. But when you do GeoEnrichment, you want to ensure that you don't just add all the variables and you only send the requests that you need to make. More information can be found on developers.arcgis.com/features/demographics, and you can dive into that topic further. Moving back to the API, there's certain parts of the API. It consists of 5 functions and 2 classes. We have get countries, create reports, enrich, which we already saw, which it takes a given geometry and adds more statistical information to it. We have a deprecated function called find businesses and then a standard geography query. The get countries method returns a countries class, and that allows us to start accessing our our information and get the named and known areas for a given location on Earth. And then from each subgeography, that's considered a name area. And then each of those is associated with a geometry. Study areas can be four things. They can be an address, which can consist of multi-lines and single lines, a point, line, or polygon geometry, a buffered study area, or a named statistical area. And we're going to go along and show some examples of this, and we're going to do a deep dive into the GeoEnrichment API. So let's go ahead and switch over to our notebook and continue on. So we talked about before how GeoEnrichment can take information and provide facts about a given location. And this information can be about people, places, businesses, and it can either be a specific area, an address, or some other piece of geographical information. Now we're going to go ahead and show you how to do that. First, it requires us to be authenticated with our enterprise or online. In this case, we're going to use online. So I'm going to perform my imports, and then I'm going to go ahead and I'm going to log into ArcGIS Online. To look at the coverage, we're going to use the get countries function, and this is going to return all the countries that are available for GeoEnrichment at this moment in time. And we can see that there's 136 countries available with GeoEnrichment data. Just like a list, we can use slicing and pull out the information that we're interested in. Here we're showing the first 10 because Python is a zero-based language. We start with 0 and it goes to 9 and then displays it below. It's great getting all the information, but let's take advantage of some of the neat features of Python and use list comprehension to filter out only information that we want. So let's say we're interested in specific continents. First, we can go ahead and we can look at the properties for the countries and see what continents are available. Once we have that, we can go and filter out. So in this case, I'm interested in Oceania. So I got the spelling for my set, put it in as my conditional for my list comprehension, and now I can see all the countries that exist within that area, the continent area that I'm interested in. Now we're ready to discover some information. Let's say we decided on Aruba. So how do we get Aruba's information? We take our country class and we do .get, and we provide the name of our country, in this case Aruba. And we get back a class that works with Aruba. And this consists of a set number of properties and information, such as the name, which would be Aruba, the three-letter abbreviation, the continent it's on, the units that they use there for that country, the various data sets, data collections, and information about the currency. On any named area that we're working with, you can access the geometry property, and you can do Aruba.geometry in this case, and get back the area that we're working with. We can then take that piece, that geometric piece of information, and pass it in as a study area. So using the enrich method, we can do study area and pass in Aruba.geometry, and let's use that the key facts that we've been working with, and let's enrich Aruba. We can see that it brings back a little more information than we had before, and it provides us with some other information. And what we did here is we ran the enrichment command. We got back a pandas data frame, in this case a spatially enabled data frame, and then we pivoted it so our columns got tilted and our columns became row values with the associated row in the second column, so it's easier to read. Now, one thing to be noted is when we're working with GeoEnrichment, the verbiage for each country and subdivision below isn't set to American standards. It actually adopts it for whatever area you're in. So for example, let's say we're working in the US in this case. We can grab the subgeographies by doing us.subgeographies, and then we can go into, it would be state, counties, and then the county name. And as we dig down further into the API, we can see that you keep getting each the verbiage for each level continues on. And then we can either gather information at all various levels. So we have state, zip code, named areas, named statistical areas. So let's take an example of that. Let's say we want to look at Washington, D.C., and we want to get the District of Columbia on there. So I'm going to draw the geometry on my map. So we have a nice visual of what Washington, D.C. looks like. So I create a map and I tell it to zoom to Washington, D.C. It takes that extent of Washington, D.C. and plots it on the map, and we have a nice looking display here. I can do my map.draw, and without having any data local or a web service, I can just do us.subgeographies.state. Then I pass in the District of Columbia, and then I say .geometry. It's the same thing we did before when we did the enrich method. We can go ahead and we can plot that on the map. Now we have spatial information without actually having the data held locally. Let's look at how this works for a different area around the world. In this case, we're going to do India. So I'm going to do country.get, and I'm going to get India, and then I'm going to start going down to the subgeographies. Now, in the United States, after we got to state, and we said the state that we were interested in, it was counties. In this case, taking the verbiage of India, it goes down to districts and then subdistricts. Instead of county and town or county and zip code, it takes the verbiage of the area that you're in. And that's very important when you're doing analysis, because you don't want to have everybody adopt to you. You want to take the local customs and the way that they view their data. So let's do something else that I find quite interesting. We can also search this data using the country.search method. And let's say we want to find a specific piece of information in the United States, and we want to find all areas that are called Washington. Maybe we know we want to work in this area, but we don't know exactly which one. I'm going to go ahead, I'm going to do us.search and type in Washington, and we find 516 areas that are named Washington. And we can just take a view of some of them and see most of them are cities in this subset that we took. But let's find ones that are a little more apt to what we're interested in. Let's say we want to find only cities. We can go ahead and we can take for each level, we can find the area that we're interested in. So we have the USA as a whole, we have the states, we have this congressional districts, counties, and we saw the breakdown. So let's look at places. So let's go ahead and do that. So instead of filtering all as a whole, we can say that we can just only want the US places. And if we were to rerun that and see how we've limited our search just by saying the type of area that we went from 516 or over 500 to 43. And that's just one way that we can get information. We can pass in the area that we want to enrich. You can also take your own geometries as well. And let's sort of dive a little deeper into the various study areas that we can accept. We talked about it in the slides, but we can accept addresses. And this can be both the multi-format where you have your address, city, region, or state, and postal code all broken down into individual columns, or it can be a single line geocoder as well. It can be points, lines, or polygons, and we can pass that in, or we can take it directly from a spatial-enabled data frame. We can use what are called buffer study areas. If you noticed before when we did the map example, when I clicked on the map, it returned back a polygon. And by default, what it does is it takes an area from a single point and it buffers it by 1 mile. And you can specify the size of any buffer you want when you click on there. And it can be in miles, kilometers, minutes, if you're using drive times. You can use network service areas as well with the buffered study areas. The way you would do that is you would do buffered study areas. You pass in your point location, your radii, and then the important distance here between what we saw in the previous area by using distance, you would say time. And that's really the trigger to say, hey, we're going to do drive time analysis for that. And then we saw how we could use name statistical areas by breaking down and going through the various subgeographies of a given country. So to enrich one of these areas, let's say we want to find the subgeography for the zip code for Redlands. I'm going to take that geometry, that named area, and call enrich. We get back our spatial-enabled data frame for that zip location. You could pass in a whole state, and let's say you have individual counties. So in this case, I'm going to say, give me back not just one zip code or one county. I want to enrich all these information. So I'm going to pass in all counties for California. What we got back from our analysis is the top 10 results in counties within California. We can then go ahead and plot this information on the map and save it out as a hosted feature service layer by doing gis.content.import data, pass in our county's data frame that we got returned back, add it to the map, and render it. And when we're done, we can go ahead and delete it. So we can use comparison levels as well. So we can compare two levels, both the county and state, to compare different sets of information for that area. We can continue on doing analysis by both buffer and drive times. And what all this shows is that we can take our information in whatever format we have and get back rich statistical information, tabular information to help us with our analysis. And with that, I'm going to pass it over to Moet.
Thank you, Andrew. So let's talk about data collections and analysis variables, see what they are. So data collections are a pre-assembled list of attributes that represent various factors, such as various socio-demographic and economic factors, such as age, population, income, race, healthcare, etc. The analysis variables are the unique variables that form a data collection. So for example, if you're looking at population data collection, you may see various variables such as total population from the age of 0 to 10, 10 to 20, and so on. And one of the easy ways to browse through the various categories of data collections and then look at the analysis variables is the data browser tool. Let's take a look. This is the data browser tool that shows various categories in which the data collections are included for a particular state. Here we see the various categories for US. We can change from the dropdown, we can change the country from the dropdown and see the categories for UK. UK has fewer categories. Jumping from back to the United States. So let's say we want to explore population category, and within population, we want to look at the data collections available for gender. So these are the 3 data collections that are available for gender. And if I click on the drop down, these are all the analysis variables within this collection, the 2025 age 5-year increment collection. So if I were to enrich my data with this collection, all of these 66 variables will get added to my data. So data browser is one quick way, but all of this can be done through the code as well. Let's jump to the code. So we'll start with data collections. The get countries method allows us to get the countries for which data collections are available. Running this cell, we can see that the data collections are available for 136 countries, and we list the first few countries here. To look at the data collections that are available for a particular country, we can use the data collections property of a country object. Here, we create a country object by using the .get method for United States. So we create a country object for US. And then we can look at the data collections property to identify the data collections available for US. This returns in a data frame. We see that each data collection has a data collection ID, a unique data collection ID. The analysis variable column shows the analysis variables that are in that collection. There's an alias field. The field category is a description of the data collection, and the vintage column represents the year. In the results, we see that this data frame has some 17,500 rows or records, and the data collection IDs don't seem to be unique. We can operate on the data frame to find out the unique data collections that are available. Running this cell, we see that there are 149 data collections, unique data collections for US, and we'll list the first few here, such as housing, population, age, etc. Now that we know the data collection, we can look at the analysis variables that are available in a particular data collection by operating on that data frame. So here we look at the analysis variables for age data collection, and running this cell, we can see the unique variables that are available for age collection. So again, if I were to enrich my data with age data collection, all of these variables will get added to my data. Here is another example. This time we look at the age by sex by race profile data collection and the analysis variables that are available in this particular collection. So now that we know what data collections and analysis variables are, let's see how we can use these for enrichment. We'll start with enrichment using data collections. Here we create 3 different study areas: a street address, a zip code, and a county level study area. Then we can pass these study areas to the enrich method, and we can pass the age data collections to the data collection parameter. And the results are here. From the results, we can see that all these 3 study areas have been enriched with the features that are available in the age data collection. Now, what if we just wanted to have a certain number of features? What if we don't want to have all the features added to our data set and we just want particular features. For that, we can use the analysis variables parameter and specify the variables that we want to enrich our data with. From the results, we see that all of these 3 study areas have been enriched with just the female 45, 55, and 65 variables. So to quickly summarize, we've looked at data collections, we've talked about analysis variables, and we have seen how we can enrich the study areas using data collections and analysis variables. Now let's talk about generating reports. GeoEnrichment allows us to generate many types of high quality reports using enrichment data, and these reports can be generated in both PDF or Excel formats. The reports property of a country, using the reports property of a country object, we can identify the reports that are available for a particular country. So since we've been working with the USA country object, we can use the reports property to look at the reports. The result is a data frame that shows the report ID. Each report has a unique ID, the title of the report, the categories this report belongs to, and the formats that it is available in, so PDF or Excel. In this case, what we see here is both formats. We can also look at the unique reports that are available for US by operating on the data frame. So the results we see, there are 53 reports available for US. Reports can be created for various study areas. Let's look at 2 examples of creating reports for a single line address and a buffered study area. We'll start with the single line address. The create report method can be used to create a report. Here we use the create report method and pass a study area to it. We pass the Esri headquarters address here. We look at the business summary report as the report type. We specify an export format, in this case PDF, and then we specify an output folder and a name for our report. Once a report gets generated, we can take a look. Here's a screenshot of our report. From this, we can see towards the left various businesses that are in the study area and the data for those businesses. Next, let's look at creating a report for a buffered study area. Here we create a 5 and 10 minute drive time buffer area around the Esri headquarters using buffer study area method. Now we can pass this buffer study area to the create report method. In this example, we again create a business summary report, this time in Excel format. We specify an output folder and a name for the file. Here is a screenshot of the report. Here we see the businesses on the left, the various types of businesses on the left, with a 5 and 10 minute drive time buffer and data for these buffers of the businesses. We can also customize these reports. The report's headers, such as title, subtitle, logo, can be customized. And we can also specify a particular data set for the reports to query. Let's take a look. We'll start with customizing the report headers. Here we create a custom fields variable by specifying the title and the subtitle that we want our report to have. Now we can pass this variable to the report fields parameter and run our cell. Here is a screenshot of the new report. This shows the title and the subtitle has been updated based on what we provided in the code. Now let's talk about specifying the dataset. By default, if a dataset is not specified, the GeoEnrichment service automatically determines dataset based on the study area. But by specifying a particular dataset, we can improve the performance of our query. So here in this cell, we specify the source country and a dataset to use. And we can use this variable in the use data parameter for the create report method. The results may or may not change depending on the dataset you're using, but the performance of the query will improve if we specify a particular dataset. Let's look at the performance comparison in the next slide. So here in this cell, we run a query to create a report without specifying a particular dataset, and we time this query. We can see that this query took 872 milliseconds. Now, let's run it again, but by specifying a particular dataset we want to use. And running this, we can see that this cell ran in 538 milliseconds. the queries ran pretty fast, and the time difference is not so noticeable here. But we can notice this time difference in more advanced and complex queries. So to quickly summarize, we talked about reports that are available for a particular country. We looked at how to create reports for different study areas, and then we looked at how we can customize these reports. Let's talk about standard geography queries. A standard geography query enables us to query standard geography areas. Earlier, we saw how study area lets us define the location of a point or an area that we would want to enrich our data with. A standard geography area similarly lets us define an area by the ID of a geographical feature. A common use case is to identify FIPS codes for various areas. Let's take a look. Let's say we want to find out the FIPS code for all orange counties in the United States. We can use the standard geography query method. Here we specify the source country, the layer we want to use, which is the county layer, and in the geoquery parameter, we specify orange. The result is a data frame that shows us the dataset ID, the layers, the area ID, which is the FIPS code, and then the name of the county and the major subdivision, which is the states. So these are all the orange counties in the United States. We can use this information to next create a study area and then enrich that area. So let's use the area ID for Orange County and enrich it. Let's take a look. Here we create a study area using the area ID for Orange County. Once this study area is created, we can pass this study area in the enrich method and specify a data collection we want to enrich the data with. In the results, we can see that using the area ID, we were able to enrich Orange County with age data collection features. We can also customize the query. GeoQuery parameter is used to specify search criteria, and we can combine multiple search terms using Boolean operators to create more complex queries. Let's take a look. In this cell, we create a query to find out orange or lake counties in California. So in the GeoQuery parameter, we specify orange or lake and California. And this returns the area IDs for both orange and lake counties within California. Now we can use these area IDs again to enrich these areas. So we create a study area with the IDs for orange or lake counties, and then we enrich these areas with age data collection. Here are the results. And the results, we see orange and lake county enriched with the age data collection. So to quickly summarize, we have looked at data collections and analysis variables, and we have seen how we can enrich our study areas using data collections and these analysis variables. We also talked about creating and customizing reports. And then towards the end, we looked at standard geography query. We've seen how to create a study area using the area IDs and how we can customize our queries. All of this information and a lot more is available in our GeoEnrichment guide series, which you can find on the Python API, on the developer's website and within Python API. This is a 6-part guide series, and this link can take you to the initial parts of the guide series. Back to you, Andrew.
Thanks, Mohit. And thank you everyone for attending this session. We ask that you please fill out the survey and let us know what you thought about the content today.